In this video, we are going to talk about indeterminate forms like 0 to power 0, infinity to power 0, 1 to power infinity in the limit of a function questions. So you have to find the limit x is approaching to a on a function f of x to power g of x. When by directly applying the limit you get either of these forms, then there are particular steps that you have to follow. Let's try to understand that in these cases how you find the solution of the limit of a function. Let's start with the problem. We have to find the limit of a function 1 plus x to power 1 over x when x is approaching to 0. Since every question of limit begins by directly applying the limit, so we can see that when we directly apply the limit on 1 plus x to power 1 over x, we get 1 plus 0 to power 1 by 0. 1 to power 1 by 0 is infinity. So you got 1 to power infinity form, which is an indeterminate form. So whenever you get an indeterminate form like this, like 1 to power infinity or infinity to power 0 or 0 to power 0, you have to follow these steps. First of all, let's call y equal to this function, which is 1 plus x to power 1 over x. Take ln on both sides. Ln is natural log. So when we take ln on both sides, this is what we get. Now there is a natural log property. Ln of a to power b could be written as b ln a. So in our question we will have ln y equal to 1 over x ln of 1 plus x. We can rewrite it as ln of 1 plus x by x. Now apply the limit on both sides. Since limit was limit x approaches to 0, so we will apply this limit. Limit x approaches to 0 on both sides. Limit x approaches to 0 on the right hand side also. Now let's solve the right hand side first, meaning this side. Treat this side as just a separate question. So if it's a limit question and you directly apply the limit, what you get? Ln 1 plus, in the place of x you have 0 divided by 0. Ln 1 over 0, ln 1 is 0, 0 by 0. So we know that whenever we get 0 by 0 or infinity by infinity, we can apply the L'Hopital rule. So L'Hopital rule says derivative of numerator. Since in numerator we have ln of 1 plus x, so its derivative is 1 over 1 plus x, and then the derivative of the inside term, which is 1 plus x, its derivative is 0 plus 1. So we have calculated the derivative of numerator divided by derivative of denominator. In denominator we have x, its derivative is 1. We have applied the L'Hopital rule. Now after applying L'Hopital rule, we will simplify this expression, which is 1 over 1 plus x. After simplifying this expression, we will apply the limit, which gives us 1 over 1 plus 0, which gives us 1. So we have solved the right hand side. Now let's look at the left hand side. So we have limit x approaches to 0, ln y equal to 1. Now we can apply the limit inside, take ln out. So we have x approaches to 0, y. We know that ln could also be written as log with base e, and inside we have limit x approaches to 0, y equal to 1. Now there is this log property which says if you have something like log e a equal to, let's say, b, then this logarithmic expression can be written in the form of exponential expression. Here this base, you write it first, and this number b becomes the power equal to, and this number written on the side of log comes here. So a logarithmic expression is now written in the exponential form. The same way we will apply it here. You write the base first. Here base is e. On the other side of equality, whatever is written, it becomes the power equal to, and the thing that is written with log, it goes on the other side of equality. So we have limit x approaches to 0, y equal to e. Now remember, we had assumed in the beginning y, which was equal to 1 plus x to whole power 1 over x. So we will write here the value of y. Limit x approaches to 0, y was 1 plus x to power 1 over x, which is equal to e. So you can see that this is what we wanted to find. Limit x approaches to 0, 1 plus x to power 1 over x, and our answer is e. So just know that whenever in a limit question, specifically of this type, by directly applying the limit, you get either of these forms, 0 to power 0, infinity to power 0, or 1 to power infinity. This is how you will start your question. You will call the expression as y first, take ln on both sides, apply the log property, power comes on the side, write it in a simplified form, and then apply the limit on both sides. On the right hand side, treat it as a separate limit question. When you directly apply the limit and you get 0 by 0 form, apply the L'Hopital rule. After applying the L'Hopital rule, simplify your question, and after you have solved the right hand side part, deal with the left hand side part. Bring the limit inside and ln outside. Ln is also written in the log e form. Turn that expression into the exponential form. Put in the value of y, and you are done with your question. So this is how you will treat every indeterminate form of the kind 0 to power 0, infinity to power 0, 1 to power infinity.